Then let's speak about what is called as control plane policing, or CoPP. Now this is a feature scoped to limit control plane packets from overwhelming the router's CPU. For example, you would want to limit the number of EIGRP and ARP packets, or the size of the EIGRP and ARP traffic that is acceptable to be sent towards the CPU. So this looks like a very important feature, which you might think that is going to be heavily and quite often implemented, but actually it's not the case. Because imagine the following use case. Like if you have a router in a certain portion of the network, and you're going to limit so that the router cannot receive more than, I don't know, 10 packets of EIGRP per second. Now, to come up with that number, you have to perform testing in your current network and take into consideration all of the possible use cases that maybe the whole network goes down, it restarts all over again, and then see, based on that worst use case, what is the maximum number of EIGRP packets per second that your router is going to receive. Because if it's 15 and you configure 10, maximum 10 packets per second, it means that when something like that happens, which can happen, the whole network to melt down and then come back up, it means that at that point your router is not going to be able to process all of the received EIGRP packets, and none of the routers will be able to do that in the end. So that's going to cause a domino effect, and it may take a very long time for the network to converge, because each router has to retransmit a lot of EIGRP packets back and forth. So it is an interesting and good feature, but in order to implement it, it requires a lot of testing, and it requires to be deployed in a network of which, let's say, size from the control plane point of view, like the number of devices and the number of routes, for example, that size doesn't grow, or doesn't grow significantly over time. Because if the whole network of EIGRP routers goes down and you have 10 routers, when the network comes back up, it's going to be, let's say, up to, I don't know, 20 packets per second of EIGRP. But if the network grows from 15 routers to 50 routers, there's going to be much more in EIGRP packets per second within the same scenario. So you see what I'm trying to say here, is that within a network which is constantly changing, is constantly growing, this feature is not likely to be implemented, because it has to be constantly retested and the configuration has to be constantly readjusted, which is a lot of work. So this is a very good feature, but you would go ahead and implement this in most use cases in networks that have been configured, activated, and they're running, and there are very few changes from the number of devices point of view and from the number of routes point of view, for example. If you want to secure the control plane only for routing packets, for example, so limit the number of routing protocol packets that can be received, accepted by the router's control plane to be processed by its CPU. Now, of course, if you don't want to go that way, what you can easily do is, assuming you're going to go ahead and test your router and see if I'm going to hit the router, basically you're going to do some tests like the following. You're going to say, I'm going to hit my router with EIGRP packets and see at which point, at which number of EIGRP packets will my router go to 90% CPU. And if your specific model of router is going to need 100 EIGRP packets per second to go to 100% CPU, then you just can configure a basic threshold saying, because I don't want to go there, I want to make sure that my router doesn't accept more than 80 packets per second, because based on your testing, you end up with the results that 80 EIGRP packets per second overload make the router CPU to go to 50% or 60%, which is good enough, for example. So if you want to be very strict, it requires a lot of testing and a stable network which doesn't change in the number of devices and the number of routes, for example. But if you just want to make sure that the router doesn't crash, to protect the router from being overloaded, then you can just pick up which protocols you run in your network, like ARP, PIGRP, BGP, whatever, and then test all of your devices and see what is the maximum number of EIGRP, BGP, and ARP packets that I can hit the router's CPU with in order to crash, or in order to hit 80 or 90%. And then you configure thresholds to make sure that you don't allow that to be happening. So it's two use cases that you can go ahead and implement. Configuration of CoPP is going to be highly reliable. Is going to rely on what is called the MQC, or the modular quality of service framework or syntax, which means it's going to make use of class maps to match on protocols like on EIGRP or ARP. Then you're going to call the class maps within policy maps to define actions for the mesh protocols. Like you would want to maybe drop all BGP traffic because there's no BGP traffic in your network, or you may want to limit the number of ARP packets per second. So you got to define the action that you want the router to take for specific protocols. And then the last step is going to be to enforce that action by the use of service policy command. So it's regular MQC command syntax, which of course this means that you're used to that syntax by implementing regular quality of service on the iOS devices.